What is a probability distribution? You had to skip ninth. Oh, okay, I see. Yeah. These are all great things to... I mean, this worksheet doesn't look so bad so far. Maybe this part looks bad. Sorry, when we start doing the... Do you guys have some... You have, like, some actual integrals you have to solve? Yeah, here you go. Yeah, this is the 1D potential well, Jamarcus. That's what this is. Also, let me make sure this is running. It's not working. Yeah, there we go. Activate. Activate selected. Cool. Activate. Yeah. This right here is, yeah, the 1D infinite potential well. This is a very, very common question in quantum mechanics. Requires you to understand how wave function operators work. Yeah, so here you have this. This is called like E phi, which I forget. You learned that like E phi equals sigma phi or something? Yeah, that's the first well you learn. Exactly. Yeah. It is the first well. And then you find what the allowed, the allowed energy levels, this is why it's called quantum mechanics, by the way, is because the allowed energy levels are quantized. Like they only occur in certain like integer steps, basically. So yeah, that's why we call it quantum mechanics. Yeah. Calculate the value of the superposition. Yeah, what this is a calculation of what the average position is. You'll learn this in quantum. This right here means like average. And what you're doing is, this right here is a probability combined. What year is this? This is college. This is quantum mechanics. It's very intro quantum mechanics. But this is like the probability. And what you learn is that if you sandwich like different values between these probability wave functions, you can then figure out what the average whatever is to happen. I agree that it's a little advanced for yeah, come back later. Cool, you're good. Nice. Yeah, it's a little advanced, but it's cool. All right. Nice. Yeah, if you come back to Marcus, I'm happy to run through this. These are fun questions. But let's see. I do have a question already from Odin Root. Odin Root, you submitted one, yep. Ooh. Yeah, this is index of refraction stuff. Okay, cool. All right. Let's throw some physics here and start things off. Okay, cool. All right, welcome everyone to Office Hours. My name is Dr. Cole. This is Actual Education, stream that helps you with math, homework, science homework, all sorts of stuff. Today we're going to be doing some what looks like this is physics. Again, if you're just joining us or you have any sort of math or science question, please feel free to submit a question using the link below, actualdiscord.com/submit. It's a good way for you. Just take a screenshot of what you need help with, and I'll go through it. I don't know why my TikTok chat isn't working, but yeah. Yeah, you remember from PChem, you had to find the probability of finding electrons from a wave function? Exactly, yeah. That's where that comes from. Okay. A light ray in air strikes the right angle prism as shown in this. The prism at an angle... Okay, B is that angle. The ray consists of two different wavelengths. Great, okay. When it emerges from face AB, it has split into two different rays that diverge from each other by 8.5 degrees. Find the index of refraction of the prism for each of the two wavelengths. Oh, okay, cool. Nice. Yeah, this is an optics question, which I need to remember my equations for index of refraction. I know the classic one, right? This is Snell's law. When you say, what is it? N1 sine theta 1 is equal to N2 sine theta 2. Yeah. But then I need a dependence on the wavelength, right? What's up, Fembox? Good to see you. Jeff, on a 10 stream streak. And you stayed up pretty late with us, Jeff. I saw. I said goodbye to you after you left, but yeah. We had a really late stream last night. I think I went for 3.5 hours. Yeah. Okay. You almost made it all the way. You're very close, yeah. Yeah. Okay, so the light comes in. I feel like it would reflect, because what we say here, right? The n here is equal to 1. So the index of refraction of air is just 1. This is going to be equal to like something. And then it's exiting again at air. Okay, very cool. So, okay, I understand now why it doesn't refract coming in. Because, so whenever you look at this, like this sine theta for Snell's law, this is the angle of incidence, which is measured from like this horizontal line. So if something's coming in exactly at this, the angle between the two is 0. And so if the angle is 0, then n1 sine of 0 is just 0. And then this is n2, so this angle also has to be 0. Okay, that doesn't really help us very much, right? But when the thing is exiting, okay, cool. Now this has some mystery n. This has an n equals 1, and then there definitely is an angle of incidence, because the angle of incidence is always normal to the plane of like, we say like the boundary. And so in this case, the plane of the boundary would be this, right? This would be the, well, I guess, yeah, this would be the 90 degrees that you need. Okay. And so if this is 30 degrees, okay, and then this is 90, and then we want to figure out what this is. Oh, you know how you can do this? Oh, this is cool. You can do this from transversals if you really want to. So I always like to think, let's draw 2 parallel lines. I am a professor for sure. Yeah. Yeah. U substitution. That's a great question. I like U sub. Yeah. Send me a U sub question. I'll do it. Okay. This is what I like to draw, right? I know that this angle must be the same as this angle, but then this angle plus this angle plus 90 must equal 180, right? So I know that this plus this must be equal to 90. So that tells me right away that this angle right here is equal to 60. Yeah. Okay, I still need to figure out why the wavelength is changing, because there's no wavelength dependence on this. Okay. They do. They do. But I'm thinking just between an interface, right? Just when you go from like one end to a different end, you should always be, you're always just looking at the index of refraction. Oh, okay. Wait a minute. Refractive index depends on the wavelength. Oh. Tricky, tricky, tricky. Uh-huh. Let me read up on this a little bit more. Da, 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 da. Right. Yes, because also inside mediums. Uh-huh. Okay, so it's good to think about like what the definition of index of refraction is, right? So index of refraction is equal to C over V, right? It is Snell's law. Yeah. Oh, I see. Yeah. So let's remember, N is equal to C, and then what's up, Zach? Oh, I need to get you a picture. Yes, I'll get that to you later today. Yeah. So yeah, index of refraction is equal to c, and then this is the velocity of the wave in the medium. And so if something is traveling at the speed of light in the medium, right, then the index of refraction is 1. Yeah, okay. So that's for things, that's for light, and that's what we say, right? The speed of light is defined as the speed light travels in a vacuum, where the index of refraction is 1. If something travels slower in a medium, right? So then let's say this was like 0.5 c. Now n would be equal to 2. I see, okay. And we're saying that that velocity now depends on the wavelength. And that's also true. Because v is equal to f lambda. Right? This is another thing you learn. The velocity of a wave is equal to the frequency times lambda. And then here's the other important thing, is that the frequency of the wave does not change in different mediums, but the wavelength does. So really what we end up saying is that, like, this velocity is then a function of lambda. Ah, okay. But not a frequency. Okay. But then how does this fit in the math? Teach me how to find the area of an atom. Well, that would take a while. Let's see. Apex angle A and minimum deviation delta. Where's that 15 coming from? Okay. There's a prism formula. I don't like memorizing formulas for things, but apparently there is like a prism formula. I want to know where this comes from though. A prism formula. What is it? Deviation. That's what this would be. Yeah, here we go. Jesus, what is this? What? Oh my god, what? Oh no. What? Dude, this is why I hate optics sometimes, dog. Okay, here we go. There we go. This is what I want to see. Okay. Alright. Uh-huh. So n of the prism divided by n naught is equal to 1/2 sigma plus delta over... Yeah, thermo is tricky. What's up, Haji? I generally don't like this. I don't, unless, is this an equation, Odin, that you get? This is optics is what this is. And one sec, I need this to work, dude. What? I would like my oh, sometimes I just have to do this, I think. One sec. That's not me. Sometimes this works. There we go. Yeah, I am live. Oh, I don't know why it wants me to log in or something. One sec. Let me try this. I think this might work. The Dirichlet kernel. Okay. One sec. Do this. There you go. Scan. Log in. Okay, there you go. Now it works. Perfect. Okay. Yeah, now my chat should work, right? Come on. Nice. Okay, there we go. No, if you need help with physics too, yeah, for sure. I can definitely help. Just there's a queue down there. You can submit screenshots and things to go through. Okay, I don't know if I like this though. Tell me, Odin, is this something that you get standard that you have to go through this? Wikipedia Snell's law, and you'll see it. The law follows from Fermat's principle of least time, which in turn follows from the propagation of light waves. Yeah. Oh man, the Deersley kernel. What is this? Oh, but yeah, you're right. Kind of looks like this. Oh god, what optics is this? I love that we all have similar opinions on optics. Yeah. I mean, this is us just trying to find the standard. It's at the top. Oh, at the top thing. One sec. Yes, I know Wikipedia. You want me to donate. I see this. Is this kind of what we're saying? Oh, and it relates to Fourier series. Ooh, nice. Yeah. It looks similar to this. Yeah. So this is what we learn. Is that white light by its dispersion in a prism. Can you explain derivatives like I'm 5 years old? Derivatives are slopes. Rate of change. I'm still confused where this delta is coming from. Because they say we have two different wavelengths. Oh, wait. Find the index of refraction for the prism for each of the two wavelengths? Oh. Oh, this is easy then. Sorry. This isn't as crazy as I thought it was. Sorry. We don't need to know the wavelengths. They're just going to have... Oh, I see. Based on your wavelength, the prism has a different index of refraction? Yeah? I think that's kind of what we're saying here. So, okay. All right, so light wave comes in. Sorry, that just like blew my mind on that index of refractions are specific to wavelengths. So this comes in at 60 degrees. So I'm just going to say, we're going to call that just N. So we're going to say N sine of 60 degrees is equal to, and then you have to figure out what the difference from the angle of incidence is on this one. So here. So that's going to be this one. So that's normal to here. Okay. And, okay. So many angles we got to play with here, right? Uh-huh. But if this is 30 degrees, this is 30 degrees, yeah? So 30, but this is 12. And then this must be 90, so that tells me this is 60. Oh, also because these are opposite angles, right? Okay, cool. So for the first one, that angle is going to be 72 degrees, right? So then this is going to be equal to the index of refraction in air, which is just 1. So I'm going to say 1 sine of 72 degrees. And yeah, let's call that NA. And then NB sine of 60 degrees is going to be equal to 1 times the sine of 72 plus 8.5. So that's going to be 80.5 degrees. It's basically 1. Yeah. We assume it's 1, basically. How do I pass calculus 2 and 3? Do practice problems. That's what I would say. Okay, so then let's just solve for this, right? We can solve for this, right? So NA is equal to the sine of 72 degrees over the sine of 60 degrees. And then NB should be equal to the sine of 80.5 degrees over the sine of 60 degrees. I think. You let me know, Odin, if you have the answer for this one. I'm curious. But let's pull out the calculator. Okay, so sine 72 divided by the sine of 60. That's going to give me index of fraction of 1.098. Cool. And then if we look at B, which was a sine of 80.5, divided by the sine of 60, that gets me 1.14. Or we can say 1.139. Yeah, okay. Let me know. Is that correct, Odin, for what we need there? Aaron says, hey, can you help me solve a system of equations, inequalities, and graphing them? It's so confusing. I definitely can. So, for everyone watching on TikTok and stuff and whatever, there's a website that if you submit a screenshot of your question, right here, yeah, please send it on Discord. Let me see it. I'll do the question. So, just go to the website there, actualdiscord.com/submit. Put in whatever username you want me to call you, and then drag and drop a screenshot of a sample question you have. So that can be like a homework question, or I don't know, like a quiz question, or in your case, Flick Fever, maybe your test. Send me what your test was, and I can go over one of your questions on the test to make sure you're getting it. Doing the problems helps you solve them. That is true. W, yeah. Yeah, I'm curious to see what the solutions manual says to this. Okay, let's see. Odin sent me the solutions manual. Okay, so yeah, it says Snell's law. So, 1.14. That's what we had here. And also 1.10. Nice. Okay, cool. So we got it right. Great job, guys.
Well done.
Yeah.
Well done.
So Aaron's asking, so would you say the best math studying method is doing practice problems and watching videos? Yeah, no, you should always do. Always do first is what I say. So you should always be doing problems first. And then if you don't understand how to do problems, you can watch videos to help you learn how to do them. Or you can hop on our stream here and submit a question, and I'll do it live here. I'll teach you. But there is no try, only do. Yeah, you have to attempt. You have to like put in the effort. You know, you can't just think about it. You can't just read about it. You have to do it. Think about if you went to the gym, right? And you said, I want to get strong and get muscles, but all I'm going to do is watch YouTube videos on how to get strong and, you know, read books on muscle building or whatever the fuck. You're not going to get any stronger, right? Nothing happens if you just keep reading books and watching videos. I mean, you'll get more knowledgeable about it, but if you want to see actual results, you have to actually do stuff. Taco Cat, there is going to be I'm being interviewed tomorrow on a pretty big stream at 11 a.m. I'll announce it in the Discord. So yeah, homework is great. Wolfram Mathematica is awesome. I've used a lot of Wolfram Mathematica. It's kind of like the OG ChatGPT for math, and really like before Desmos and stuff. Gold, what is your dream? What do you mean, what is my dream? Live? Yes, live. Yeah. What is my dream? My dream is to keep doing this forever. It gets boring, but you learn. Yeah, no, again. And if you're getting all the questions right on your homework, you can move on to stuff you don't get right. You don't have to keep doing the same stuff over and over again if you keep getting it right. Like, whatever. Like, you learned it. You're fine. What do you want to accomplish? Oh. That's a good question. I had someone ask that to me today in kind of like a job interview. They said, like, what's your ultimate life goal? And so I said, my ultimate life goal is to pass the baton to as many people as I can. So I see this as, you know, passing the baton of knowledge to as many of you guys as I can so that you can keep running with the baton long after I'm gone, because I won't be here forever, unfortunately. I think it's something as you get older you start to realize death is inevitable. But if you pass enough batons, I think the spirit of what you do lives on through the progress of the human race, which is dope. Will it really matter once AI takes over? Yeah. Yeah, again, because AI still can't replace building the knowledge and building the skills. What subjects do I teach? I teach everything math and science, middle school up through college. Some grad level, but yeah. How to draw an acceleration versus velocity graph? Sure. I can do some static engineering. Some of that stuff gets weird. Yeah. It's okay if AI is running the courses. You still have to learn how to do things. Think about this as like you just got like a new gym instructor, you know, but it's like a robot. You still have to go out and lift the weights. You still got to do stuff. If you don't do stuff, you don't get stronger. Where? Okay, yeah. So nice. What's up, Becky Beck? Good question, Odin Root. Appreciate that. Why do we have to learn if AI does it all? Because eventually you have to do creative thing. Like, what's the purpose of life, right? The purpose of life is to create and to enjoy and to innovate. And I don't think AI is very good at those things. AI can't make you happy by doing things for you. You have to do things to make yourself happy. And finding the ability to do things requires practicing doing other things. Celestial mechanics. Yeah. Y'all can send me screenshots. I'm waiting for someone to send me a screenshot of something. Everyone's talking big talk, but like, I gotta see a problem. I won't push the point. No. Please push. I love pushing. Let's see. I have no clue what this one is. What? Sine 2x, secant 2x? All right, here's a question from Rainy. You can always push it. Wait one sec. Most of us can drive cars, but few of us know how cars actually work. Won't math become like that one day? Yeah, but let's think. If you want to design cooler cars, you need people that know how cars work. You know? If you want to develop cooler math, you have to have people that know how math works. AI can't really innovate. AI can just collect. AI can just regurgitate and be very good at organizing knowledge that we've already gained up to this point. It can't really innovate new things. That's what you need humans to do. You need humans to like connect the dots in like weird ways that wouldn't usually make sense. Will the everyday person need to know math? I think learning math teaches you skills that transcend math. Like, here's a good example for this one. Find the values of x, which make the function has a local maximum and a local minimum. Sure, I could throw this into ChatGPT right now, and it would just give me the answer. But then you would lose the knowledge of, well, what makes something a local max, right? Oh, it's something where it's increasing, and then it's 0, and then it's decreasing. That's a cool concept that can be used in other things. If you're trying to maximize something, you're like, okay, well, I'm looking for where it's increasing, and then it stops, and then where it's decreasing. I know that's a very like simple example, but that's. Do you do one-on-one? I do for sure. Where do you teach? I teach at UCLA. I teach physics at UCLA. What do you think about me trying to avoid using AI? I low-key want to learn the stuff from a solutions manual or reading the textbook to fix my attention span. Sure, I use AI all the time to help myself when I can't figure out answers. It's totally fine. I think AI is better because you can ask it to explain individual steps you don't understand. But if you really want to challenge yourself, yeah, you can just look at the answer in the back of the book and try to figure it out. But I don't think there's any harm or any like crutch you're using by having AI give you the solution instead. As long as it's the right solution. Yeah. I mean, this is a cool one. So like this is a function, right? F of x is equal to 4x minus 3. I'm gonna, well, actually, I'll leave that how it is. We could break this up into x plus 1 and x minus 1. This is calculus. Calculus 1. So what we learned about maximums and minimums, okay? Maximum and minimums occur where on a function you have something that is increasing and then it's then flat, right? At some certain point, and then it's decreasing. Okay? In calculus, this is related to the derivative. This is related to the slope. I do, Bunny. Or Sunny, sorry. I took calculus in high school. And then I also took higher level calculus in college. So, if this is a graph of f of x, right? Then the slope, f prime of x, needs to be positive here. It needs to be equal to 0 here, because the slope needs to be flat. And then it needs to be negative here. Okay? And so, that gives us some clues into how we can figure out where maximums on functions are. If we want to find the minimum of the function, right, when it's at its lowest, one of its lowest points, or like that would be a global max, but a local max is like a temporary like dip. That occurs where the slope goes from decreasing to flat to increasing, right? So this would be a negative slope, this would be a 0 slope, and this would be a positive slope. So this is a concept, right, that again, I know ChatGPT can just give me the answer here. But if you understand why these critical points, these local max and local min, which are called critical points eventually, we'll get to that, are due to changing slopes, that can then help you analyze other questions when you have things like, for instance, vector fields or flow diagrams, or I don't know, whatever, where you have derivatives changing and doing things. That can help you figure out, oh, well, what's a saddle point? What's a vortice? All cool things. How do I contact you? You can DM me if you want. That's totally cool. Okay, so let's try to do this one. So in order to figure out where a local max and a local minimum is, we know that the slope at that local max or that local minimum needs to be equal to 0, and the slope is the derivative. So I need to figure out what is the derivative, or ddx, of f of x. Okay, this is the big question. This is kind of an annoying thing to take derivatives of. I'll agree. No, I on TikTok or here. So here I teach for free. If you want one-on-one tutoring, it's expensive. I'll warn you real quick. It's at least like $100 an hour. Just because that's the time I have, and I have to pay rent. And Los Angeles is not cheap. But you can get help here for free. That's what I do to try to offset things. Okay. So f prime of x, right? This is what we call the quotient rule. And the quotient rule says that when you have something on the top divided by something on, I don't know, the bottom. One second. I want a different color for this. Let's use brown. Fuck it. This is going to be equal to, and let's call this like A. And then let's call this B. How often do I go live here? At this point, 5 days a week. If you want to figure out when I stream, there's a website down there. Click it, and then there's a Google Calendar schedule. So this ends up being the derivative of the first thing, which is A prime times B minus B prime. So derivative of the bottom thing times the first. Yeah, A prime B minus B prime's A. Good. And then this is all divided by... This is what makes things ugly. It's all divided by the bottom thing squared. I know. That's the thing that sucks. You just started learning derivatives last week? Nice. Great. Yeah, so this is called the quotient rule. That's what this is. And it's how you take derivatives when you see the big picture is two things dividing each other. You could also use the power rule and the chain rule. Totally also valid. I think this is an example where the quotient rule is preferred, because eventually we're gonna like try to set the top just equal to 0, right? I don't really care about the bottom. I love the chain rule too. I have a really good video on the chain rule if you want to see it. It's on my TikTok. It's also on my YouTube. It's one of my highest rated videos. But if you go here and just type in chain rule, I have here a complete guide to the chain rule. This one has 112,000 views on it. Yeah, so this one's very popular. But I have a fun little video on the chain rule. So just go to my YouTube and type and search chain rule, and I have a video that explains it. Yeah. Okay, so let's do some derivatives here, right? So a prime. That's saying, okay, what's the derivative of 4x minus 3? Well, derivative of 4x minus 3 is just 4. Nice. GG, easy, right? And then it's times b without taking a derivative. So that's the whole thing b. I'm going to leave it in this form, the x squared minus 1, because that's what x plus 1 times x minus 1 is. So this is x squared minus 1. No. The queue is totally empty, Becky. Yeah, Becky, if you want to submit, queue is totally empty. I'm just doing like a question that someone asked from yesterday. You can submit whatever you want. Please, Becky. You can also always see the queue. If you type Q, I think, into... Yeah, exactly, Jeff. If you type Q into Discord, it'll pop up. You'll see it. Okay. All right, next thing is I need to take the derivative of b. And so that's just going to be equal to 2x. Derivative of x squared is just 2x to the first. And then that's times a by itself without any derivatives, and that's 4x minus 3. Yes, exactly. The derivative of any number is 0. The reason for that, let's remember the power rule for derivatives. So if you have, for instance, 5x squared, you know you take this thing, it comes down, it multiplies, and then you drop it by 1, so then it goes to 1. When you have a constant, which is just a number, you're still doing the power rule, okay? This is like 5x to the 0. Remember that x to the 0 is equal to 1, right? So 5 is the same thing as 5 times 1, which is the same thing as 5x to the 0. Now watch what happens when you do the derivative. The 0 comes out front, multiplies by this. That's going to kill it off. And then this technically would go down to -1, but we don't really care because it's 0 times whatever. So that's the reason why the derivative of any constant is just 0. Right. And then it's all of this is now divided by b squared. And so that's going to be our x squared minus 1 squared. Okay? So this looks a little messy, but let's expand out the top. I think we expand out the top, something nice will come out. So we got 4x squared minus 4, and then this is going to be minus 8x squared plus 6x, and then I'm going to leave this as x squared minus 1 for now, because all I really know is that I really don't want x to equal 1. If x equals 1, that'll break my denominator. And you don't divide by 0. It's like a bad thing. Don't do it.
No, God!
This is calculus, yeah. Okay. So let's try to like simplify this, right? So 4x squared minus 8x squared, that's negative 4x squared. Plus 6x minus 4. All over x squared minus 1 squared. And cool. This is f prime of x, right? This is the derivative. And what I want to do, in order to figure out where there are either maxes or mins, is figure out where this derivative is equal to 0. And if I want to figure out where this thing is equal to 0, I really just need the numerator to be equal to 0. I don't really care about this. As long as this isn't also 0. But I can see right away, the only way for this to be 0 is if x were equal to plus or minus 1, which putting plus or minus 1 into here will not get you 0. So we're safe, okay? So set the top equal to 0. I'm going to say negative 4x squared plus 6x minus 4 is equal to 0. Right away, I see I can pull a 2 out, right? You see how there's a 2 that goes into all of these things? So I'm going to divide the whole side by 2, divide this side by 2. And we're going to get negative 2x squared plus 3x minus 2 is equal to 0. And then I don't really like the negative on the front, so I'm going to multiply everything here through -1. What's up, Math Miner? Oh, that's cool. Math is great. Here you are. Okay, so this is 2x squared minus 3x plus 2 is equal to 0. Is this factorable? I think it is. I'm tempted. Because what I see, right, if I do this times this, so 2 times 2, that's equal to 4. I need things that multiply to 4 but add up to -3. Actually, I don't think that works, right? Because I can only think of -2 and -2 would be -4. 1 and 4, +1 and +4 would be 4. I definitely help with trig, yeah. Yeah, if you trig question, I'll totally help. -4 + 1 would be great, except -4 + 1 does not multiply to 4. Dang.
Surprise, motherfucker.
That's a problem. Unless we screwed up here. I don't think we did. Right? 4x², right? -4. Then this was always going to pull out some terms. So the only other way would be -8². Yeah. Surprise, yeah. Yeah, I think unfortunately it does work like that. You don't remember shit from high school? Time to remember shit. Okay, I think unfortunately we have to just quadratic this. It's a pain. The original question? Yeah, sure. Here's the original question. Will, you want to see it? It's just saying what values of x make the function a local maximum or local minimum. -2 and -1, dog? Yeah, that doesn't work. That doesn't work for the 2 being in front of here. Right? That would work if this 2 was gone. If this 2 was gone, you're totally correct that this would be -1 and -2. But because there's a 2 in front of here, you have to do more work. And actually, so okay, I'm gonna be totally transparent. It is gonna be a quadratic equation. So the student that did this thought that the answer was just 1 and -1. I don't know if that's right. I think that's probably wrong. But let's have a sanity check, right? And this is the beauty of AI is before I go further, I'm gonna do a little sanity check where I'm gonna ask AI to try to solve this. And I'm going to see what it says. Because I agree with Jeff. I think we're going to have a no solution here. Because if I look at this quadratic equation to solve, and just by looking at the discriminant. So the discriminant in the quadratic equation is this. This is the discriminant. And this will tell you whether you have one solution, two solutions, or imaginary solutions. I could put it into Desmos as well. Exactly. That's another way. So if I look at the discriminant right away, and we just do b² - 4ac, right? That's going to be 3², which is 9, -4 × 2 × 2. This is 9 - 16.
Surprise, motherfucker.
That sucks, right? We don't like that. 'Cause you can't take the square root of negative numbers, so this is already kind of chopped. Right, okay, and then here. ChatGPT said the same thing, except it fucked up its LaTeX. Dude, ChatGPT needs to fix this shit. I don't know why they fuck up their LaTeX formatting. But here we go. So here, they did the quotient rule like we did. And then they showed that it has no real roots. So there's nowhere that the derivative is equal to 0. So there's no local max and no local min. And I agree with that. I agree with that statement. Yeah. So from right here, I could already tell, like, this is a poorly worded question. Do you have to change bounds when doing indefinite integrals? Not usually, unless you're doing like U substitution. But wait, there are no bounds if it's indefinite. What? Right? If something's indefinite, it doesn't have bounds. Yeah, U sub. Yeah, but that would be a definite integral. Okay, so yeah, the conclusion here is that there are none. Nice. Okay, good. Good question there, Rainy.
Well done.
Oh, this is a great question here, Odin, coming up. I like this one. This is a really great one. I wrote a similar question like this on my when I taught this class at UCLA. I literally did this question. Yeah, send me a fun one, Will. I'm down to like C questions. Everyone asks, like, can you help me with blank? Can you help me with blank? And I'm like, yes. But you need to tell me what to help you with. You need to show me what you need to help you with. Okay, here's one. A policeman in a stationary car. I taught undergraduate mechanics for pre-meds, and then I taught undergraduate E&M, waves, and and fluids for engineering majors. Okay. Measures the speed of approaching cars by means of an ultrasonic device that emits a sound with a frequency 39.6 kilohertz. The car is approaching him with a speed of 35 meters per second. The wave is reflected by the car and interferes with the emitted sound, producing beats. The speed of sound is 344. What is the frequency of the sound reflected by the car? Okay, cool. Interferes with the emitted sound. Yeah, okay. All right, so here's what happens. We got, here, let me get like a police car. I can get fun images, right? Police car cartoon. Fuck it. There we go. This looks like a police car. Okay, so you have police car, yeah? And police car is emitting waves that are at, we're going to say like some F0, which is equal to 39.6 kilohertz. Okay. And then a car is approaching him at 35 meters per second, which is, I think, around 60 or 70 miles an hour. Pretty sure it is. At my university, it's called Physics 3, and I'm going to continue optics next week. Yeah, relativity sucks, dude. Taco Cat asked me, Gold, how did your other classes go in high school? They all went pretty well. No complaints. I mean, except for my U.S. history teacher. He sucked. All right, so let's have a car that's oh, then what's the frequency of the reflected wave? This is so cool. What is the frequency of the sound reflected by the car? What is the frequency of the reflected wave detected by the policeman? Yes. And then what is the frequency of the beats produced? Yeah. This is for physics. So, yeah, let's see. If, what car do you guys want to get? Let me think what my favorite car is. I really like a Porsche 911. 911s are nice. Let's say, Porsche, this is exactly GT3 cartoon. There we go. Yeah, I like this car. That's a cool car. I'll use this car. You've never seen a frequency question in physics? You haven't taken enough physics then. I want my GT3 RS. Yeah, there you go. I always joke as I've gotten older. I'm like, where's my Porsche? I did all the right things. Where's my Porsche? Yeah, okay. So this thing is moving towards it at 35 meters per second. Okay. So when this wave hits the car is going to observe that wave at a higher frequency. And this is due to the Doppler effect, okay? So in this case, I'm going to call this like F1, which is the sound wave that reaches the car. And the way to figure that out, right, is to do what's called the Doppler shift equation, which let me see if I know it off the top of my head. I think it's F equals F naught. I want to say it's V plus or minus Vs over V plus or minus VO. Is that right? I think it's right. Oh, it's VO over VS. Okay, so I had this wrong. Alright, it's okay. Happens. Doppler effect, correct. Yeah, so this is V over VS, yeah. Okay. Where V here is equal to the speed of the wave. Wow, thank you, Casso Prime. $1, that's sick.
Queso Prime 9 just donated $1 to Actual
That's
Education.
awesome. I appreciate that, Queso. I didn't know our donation page still works. That's sick. Yeah. This is an actual nonprofit. We actually do like nonprofit things. I mean, we're teaching for free right now. Appreciate that, Queso. Thanks, man. Okay, so this is 344 meters per second. That's V. Okay, so and then here's what the things are. So VO is the velocity of the observer. The observer is the person that is hearing the wave. In this case, as the wave is approaching the Porsche is the observer, okay? So here, this is the observer, and we say this VO is equal to 35 meters per second. Wow, another $1. Dude, we're eating good tonight, Queso. Thank you.
Queso Prime 9 just donated $1 to Actual Education.
Oh, I love that. Just keep it going, dude. Just keep spamming it. Okay, and then VS, that's the velocity of the source. So that's how fast the source is going. Notice that the police is stationary. So if the police car is stationary, then VS in this case is equal to 0. All right, so the frequency that is heard by the car, which we're going to call F1, is equal to F naught, which F naught in this case is 39.6 kilohertz. And then this is the part that always screws people up. They don't know whether to put plus or minus on the top and the bottom. I'm going to show you a quick trick how to know that, all right? So, okay. This here is going to be a fraction, right? And let's think about what frequency the Porsche needs to hear as it approaches a sound. Because the Porsche is getting closer to the car, right? That means that it should hear a higher frequency, right? And so you may have noticed this as like, I don't know, like fire trucks come towards you, you hear it going, ee. That's the frequency going up as it approaches you. The same thing would happen if you were approaching a stationary fire truck. So I need the frequency to go up. So when looking at my fraction, that means I need this to be positive, right? Because I need bigger numbers on top. And then I need this to be smaller, or I need this sign to be negative in order to create bigger frequencies. The only difference is if the cop car is moving away while this is moving towards it. Nice. But that's a harder thing. That's not coming up right now. So I can explain that. That's a different subtlety. Yeah, I can definitely help you with integration, Antonio. So if you want to submit a question, there you go. Just do that. I'll do it. Okay, so this is going to be 344. And then this is going to be plus the 35. And then this is going to be 344. And actually, I don't care if it's plus or minus because velocity of the source is 0, right? Plus or minus wouldn't really matter, okay? If the cop car was moving towards the Porsche, this would end up being a minus sign because I need the cop car velocity to make this a smaller number so that the frequency goes even higher. If the cop car was moving away from the Porsche, this would be a positive number because I need the frequency to go down. And that means I need the denominator to be bigger. Okay. So, we can just do some math here real quick. Where's my calculator? 344 plus 35 divided by 344 times 39.6. So that gets you 43.63. Okay. Wait one second. There you go. Okay, yeah. 43.63 kilohertz. Okay. E to the minus 3x sine of 4x dx. Ooh, wow. How do you get the TI-84? That's a emulator called Wabbit EMU. If you want it, here, I'll show you. It's this one. Here, this is the website for it. Wabbit EMU, if you ever want to check it out. It is free. Totally free. You have to do some stuff with finding ROMs, but if you DM me, I'll just give it to you. Okay, so the frequency reflected by the car. Yeah, that's cool. So that's going to be 43.63 kilohertz. Now, here's the cool thing. Okay, now we ask, what is the frequency of the wave reflected from the policeman? Now the situation shifts because the car has received a higher frequency wave because it's moving towards the cop. But now when the wave reflects back, the car now acts like a source. It's going to reflect a wave that's going to go even higher in frequency relative to the cop. Thanks for the Rozo. Yeah. So now we have the opposite situation. Let's get the cop and everything. Here's the cop. Okay, so now what happens is the car or the Porsche is now emitting a frequency. This is the initial frequency. This is 43.63 kilohertz. I don't know what QCAA is. Can you maybe elaborate a little bit? And now the cop here is going to be the observer. This is going to be the observer, okay? And again, the velocity of the observer here is equal to 0. The velocity of the source here is now equal to 35. And so we can use our equation here. So F, I like to call this is like F2, I guess. So F2 is now equal to F0, which is this. And then it's observer over source. Okay. So VO plus minus V source. VO plus minus V source. Or V observer. Sorry. No, VO over VS. Okay, 1 sec. I'm messing this up totally. Velocity of the wave plus or minus VO. Velocity of the wave plus or minus V source. Nice, Antonio. Yeah, thank you. I see it. I totally see it. I will get to it very soon here. Yeah. Oh, the Queensland. Oh, yeah, we do have a lot of, like, New Zealand people finding us here. That's kind of cool. Okay, so this is 43.63. So, in this case, the observer, which is now the cop, it used to be the Porsche, that is 0. So, we're going to say, okay, cool. So, that's times 344 plus 0. And then this is going to be 344. The source is now the Porsche. The Porsche is moving towards the cop. So the frequency needs to go up. If the frequency needs to go up, I need to divide by a smaller number. So instead of adding 35, which would be a bigger number, I'm going to subtract 35. And that gets me a smaller denominator, which when I divide by a small denominator, I get a bigger overall number, and this frequency should go up. Okay, so now, when we throw our calculator on, I have 344 divided by 344 minus 35 times my new shifted frequency, and that's going to get me 48.57 kilohertz. Cool? So this is the frequency now being detected by the policeman. So that's 48.57. This is literally the same type of question I asked during when I was teaching this. Okay, and then what's the beat frequency? This is cool. So the frequency the cop is emitting is 39.6 kilohertz. You assume he can hear what he's emitting, and the frequency that's coming back to him is 48.57. So the beat frequency is the difference between these two. And so that's equal to 48.57 minus 39.6, which I don't know, I'm going to round that to 48.6. So that's about 9 kilohertz. Wow, thank Queso Prime. Another $1. He just keeps running it up, dude. Love that. Good day, Queenslander. Nice. Okay, cool. So that's how you do that question. Good question. I like that one. Nice, dude. If you want to see an example of like how beat frequency works, it's really cool actually. We can do this with a tone generator here. So here, let me pause the music real quick. This is too much sound. Where's that? Where's my music? Where do we put it? I do see your question too. Thank you. I do see that one. Okay, let's mark this one as done. Okay, 1 second. Let me pause this. So here, for instance. Oh, you're welcome. You're welcome, Queso Prime. Okay, so this is a 440 hertz tone. Okay, so this is a frequency of 440 hertz. Watch what happens if I duplicate this, and we're going to play a slightly different frequency. Let's say we're going to play a frequency of 441. Do you see how that oscillates back and forth? Ooh, ooh, yeah. That's called a beat frequency. And what that is we have two different frequencies playing, and the difference of those frequencies creates like a new sound that oscillates at that difference of the frequencies. So the difference between 440 and 441 is 1. So you hear a 1 hertz beat. And 1 hertz means 1 oscillation per second. So this is 1 per second. If we crank this up, let's say this is 445. Now it's a 5 hertz beat. Okay? So notice how you hear it playing like 5 times as fast? That's a beat frequency of 5 hertz. And then you can keep cranking this up, like 449 or like 450. This would be like 10. Let's go even higher. What about like 467, right? This would be a beat frequency of 27. Okay. All right, now I'm gonna stop torturing you guys with sounds. Anyways, okay. Yeah, so that's an actual demonstration of how like beat frequency works. It's pretty cool. Man says 6-7. Uh-oh. Oh no, I triggered them. They heard the 6-7. Gotta call it, dude. Okay, cool. Which one is the bad one? Which one is the one bad for us? I mean, none of the frequencies are bad for you. There are some that are like kind of weird. All right, let me get Dom's question real quick, and then I do see yours. Just to show you, Antonio, I see this. I will do this one next. I promise. Okay. Let me do this one real quick though. You're the next one after this one. Let me do this one real quick. Okay. I think this is just similar triangles, which isn't too bad. So this says find DA over DB, or DA over AB. So they want the ratio of this to this. Oh, given that you have this to this. Pretty cool, actually. I think I can prove that this triangle is the same as this triangle. Is that true? Let's just see why. This is almost like a geometry proof thing. So I know this line is congruent to itself. These angles are the same. How do I see like side angle, but then I want either side angle side, or I want angle side angle, but I don't think I have that. But yeah, Pythagoras theorem though only works if you have a 90-degree angle in the triangle, Antonio. So unfortunately, we don't have a 90-degree angle here. I do know that the sum of these two angles must equal the sum of these two angles. That I know for sure. Because the third angle is the same. You have angle side. Yeah, we don't know if DB is perpendicular to AC. I have angle here. I don't think this angle is the same as this angle, though, man. Right? I don't know if I can prove. Also, it definitely doesn't look the same, right? This angle doesn't look the same as this angle. Oh, okay. One sec. I think there's something about angle bisector. Aha. It's called the angle bisector theorem. Oh, okay, cool. I agree that one of them is going to have the same thing for sure. But there's a theorem about this. Here we go. This is it. This is it. Okay. I mean, could we prove this theorem? I'm curious if we could. Okay, but this is what they say. Okay, so if a ray bisects the angle of a triangle, it then divides the opposite sides of the triangle into segments that are proportional to the other two sides. And what they say is that A over B, so in that case, we're going to say 10 over AB is equal to C over D. So that's going to equal to 2 over AD. Yeah, geometry never stops surprising me, right? This is cool, actually, where this comes from. Yeah. All right. So, and they wanted me to find DA over AB. Okay. So we got to solve for this. So what I do is, this is cool. This is kind of like, they call it the butterfly method, or like cross multiplying. But I can take this, move it over here, and then I can take this and I can just put it down here. Like, that's a totally legal thing to do. You can always switch the diagonals if you have two fractions just equaling each other. And then I have this, right? AD is the same thing as DA. And then AB, AB. And so that should be equal to 1 over 5. Yeah. There we go. Okay, Dom. So I think the answer is 1 over 5. Let me know. I think that's right. I don't know if necessarily this is also... So, yeah, I don't think this is 2 and this is 10. I don't think it is. I think the ratio is also 2 to 10 is also 2 to 10, but I don't think it is. It's exactly 2 to 10. Yeah, cool. All right, good question, Dom. Appreciate that. Nice. Yeah. There are a lot of different triangle theorems and circle theorems you have to learn, and they're honestly like tools. It's like having a toolbox. And then once you have these tools, you can do all sorts of like cool solving stuff. For circle theorems are like bane of my existence. What is it? I've grown to love them, but yeah, here you go. These these are like all the circle theorems, like all this stuff. Here you go. This is like a little cute little diagram of all of them. Yeah. So you have to learn these or kind of memorize them. Some of them you can kind of derive from the other ones. But geometry is all about understanding all the different theorems for wacky stuff with shapes and lines, and then using that as a toolbox to solve other similar wacky situations. I say geometry is always like the ugly stepsister of math, because it's not really much with numbers. Your shapes and lines, yeah. You want to lie tangent to my curves. That's what a derivative is. Okay, all right. Next question up here is from Antonio. Antonio thinks it's, Fembox says it's integration by parts twice. I am tempted to say yes. This is called a cyclical integration by parts. Yeah, okay. Euler's identity.
Disqualified.
No, we're not doing Euler's identity, Jeff. God damn it, what? That would suck. Okay, yeah. All right, so how this works is I gotta pick something to be U, I gotta pick something to be dv. It actually doesn't matter. So here, let's write, I'm gonna write this out just so it's a little cleaner. I'm gonna say e to the minus 3x you can't really take the e to the minus I guess you could make it e to the x. He actually does have a point, right? E to the minus 3x. No, you can't. This is the same thing as e to the minus x to the 3. Yeah, no. If it was e to the, let's say, like, a plus b, then yes, you could pull this as e to the a, e to the b. That's correct there. You could do that, you know. You want to leave this just how it is. I'm going to show you why. So, I'm going to pick something to be u. I'm going to say u is equal to e to the minus 3x. Live, laugh, love, calc 2. Yeah. And then, or laugh, love, live. Live, laugh, love. Love, live, laugh. Derivative of this is e to the minus 3x, but then it's a chain rule, because you got to take the derivative of what's inside. So that's minus 3 e to the minus 3x, and then we say dx, right? Cool. Then I'm gonna pick a dv, and my dv in this case is going to be sine 4x. Sorry, we need a dx here. Sorry, let me fix that. Dx, and so then the integral of that, integral of sine is negative cosine, but then you also have a 4x, so that's a u sub thing, so that's negative cosine 4x times divided by 4, so here, negative 1/4 cosine 4x. Yeah, you'll watch, it's a double one. Yes. It could lead to an impossible integral. In this case, it does not matter. I just need to do it twice and make sure I pick the same u and v. So, let me know. Let me make sure. Antonio, are you following along with this? I'm gonna tag him real quick. This is his question. Use the IBP rule. What's IBP? Okay. All right. So then the rule is this is then equal to uv. You're good. Yeah, Antonio, just making sure if you're following. Let me know in the chat if any of the shortcut steps I make here are confusing, and I'll go through and explain them. I did a little bit of a shortcut with usub, sorry, with the chain rule here, and I also did usub here. Oh, integration by parts. Okay, cool. Okay, so this is equal to u times v minus integral of v du. Okay? Integration parts is beautiful. Yeah, this is really cool. So let's see what we get. Right, so that's equal to e to the minus 3x times this, right, minus the integral of v, so that's this, and then du was this part. God bless copy paste. And I'll show you why, because it's going to be a little bit easier to keep track of all the minuses and stuff. Otherwise, this gets really confusing. Okay. So I'm going to leave this as it is. Actually, I can simplify it. Let's simplify it a little bit. So this is going to be... let's say e to the minus 3x all over 4... or negative e to the minus 3x all over 4 cosine 4x. I can teach up to, like, real analysis or complex analysis. Okay, but this is another difficult integral. All right? But not to fear. Let's kind of simplify it a little bit. So we're going to pull this down. All right, so I see a minus and a minus, so that's going to end up being a plus. And then I see a 3/4, so I'm going to pull that out. I'm going to pull that positive 3/4 out, because we just don't need it. So 3/4 integral of cosine 4x, and actually, then there's still an e to the minus 3x dx. If you want to figure out how often I stream, website down below, that actualdiscord.com/submit, there is a Google Calendar link there that you can see all the times I stream, which is about 5 days a week. Oh, okay, cool. I can try to help you with complex. Okay, so this turns into this. This is another scary integral. Okay, but we're gonna do integration by parts again, and make sure you pick the same thing for u and v. So I'm gonna pick the e part as u. So I'm gonna say u is equal to e to the minus 3x. Then du is equal to negative 3 e to the minus 3x. Let's say that dv is equal to cosine 4x dx. So then the integral of that v is going to be equal to 1/4 sine of 4x. I have a physics PhD. That's my degree. Okay. And so now I'm going to turn this into uv minus v du, right? So, same thing. We're going to say... yeah, no. I'll show you. I'll show you why we need to choose the exponential as u. Because we did it the first time, we need to do it the second time. You're going to... watch this. This is going to blow your mind. You're going to be like, oh my god. Watch this. It's pretty cool. Okay. So, uv... my undergraduate was in physics as well. So that's going to be this. So u v, and then minus v, and then du is this. Oh, and then I forgot a dx here. Ooh. Don't forget the DX. God bless you, Dr. G, for spreading some knowledge to the TikTokers. Yeah. No, I first really got big on TikTok, honestly. That was the first thing that really kind of got me an audience. Actually, a lot of people in my Discord found me from TikTok. Okay, so let's try to like simplify some stuff here. Okay, so then this is going to be e to the minus 3x over 4 sine 4x, and then this part right here is going to be plus 3/4. Let me see what it is. Plus 3/4 sine 4x. And actually, here, let me move this a little bit. So minus minus is plus. A quarter times 3 is 3/4. And I'm going to say this is e to the minus 3x sine 4x. Why is it a plus? Good. Okay. So there's a minus here from the minus v du, right? And then v was positive. But du, because we took the derivative of e to the minus 3x, that became negative 3 e to the negative 3 dx. So I have a minus here. I have another minus from here. And those two minuses make it a plus. You got to keep track of the minuses and the pluses. It's actually a real pain in the ass. This counts as studying? Yeah, dude. It's better than doom scrolling through like feet pics and like thirst traps. Okay. Okay, so this. Oh, I did forget the integral. Sorry. Oh, I need to. Oh, wait. Yeah, wait. Thank you. I didn't even integrate yet. Yeah. Sorry. 1 sec. Thank you. Or actually, ooh, I shouldn't have deleted that. Fuck. Can I undo that? Yes. Okay, cool. Yeah. The one thing we forgot here. This is still an integral, right? It's integral of v du. Okay. All right. So, big picture, right? We have this is equal to this, which is this, minus this. This v du was all of this, which is then all of this. So our final thing is this. So that's this part was equal to uv from the first integration by parts, which was this. So we're going to say equal to yeah. Oh wait, no, that's my calculator. There's a Q, Becky. You're next, Becky. Is equal to that. And then minus, right? And then this is 3/4 times whatever this was. But whatever this was all of this. Okay? So now we're going to pull this all in. Okay? All right. Good so far? And this is, sorry, dx. Let me know, Antonio, if this is good so far. Yeah. Okay. So again, you're here? Okay, cool. Just making sure this makes sense. Okay. Here's the cool thing. This integral right here, e to the minus 3x sine 4x dx, is the same thing we started with. So we were trying to figure out what this integral was, and by doing integration by parts twice, we got a bunch of shit, a bunch of like nasty stuff. But then we got our original integral back at the end. This is very cool. Okay, this is a really dirty example because it has usually it's like e to the x sine of x, and this is very clean to see. But because we had e to the minus 3x and sine of 4x, you kept pulling out all these factors or these coefficients that mess things up. But okay. The cool thing here is, okay, if I distribute this 3/4 now into everything, right? So let's just do that. So this is going to be minus 3/16. Okay, and then the minus sign is going to go in here, and this is going to be also minus 3/16. Or minus 9/16, I guess, yeah. Okay. Now what I can do is I can take this entire thing here, and I can move it over here, okay? So I'm going to add 9/16 of this thing, okay? So let's do it. Let's say like plus 9/16 integral e to the minus 3x sine 4x. And so 9/16 of this integral plus 16/16 of this integral is now going to be 25 over 16 of this integral. And that's going to be equal to whatever was left here, right? Which is this.
Nice.
And so the last step is to just divide both sides by 16 over 25. And so what you're left with is 16 over 100. This 16 will cancel with this one. So you just get 3 over 25. And then this should be your final answer. Should be this. And look, you have what your original integral is, and it's equal to this, which we could simplify this a little bit more. This is the same thing as negative 4 over 25. E to the minus 3x cosine 4x minus 3 over 25 e to the minus 3x sine 4x. Okay, cool. Nice. Good job, Nanya. Welcome, dude. Yes. Okay. If I wanted to... I smell 3, 4, 5. Yeah, dude, 3, 4, 5 needs to be the new 6, 7 for these kids, dude. I wish they'd go as crazy for 3, 4, 5 as they would for 6, 7. I can definitely do triangle proofs if you send me an example of a question you want to go through. Yeah. We're doing calculus right now. Yeah. So again, if anyone has questions they want to submit, there's a website right here. It's called actualdiscord.com/submit. I created this website. You put in your username, drag in a screenshot of a sample question. Like, this can be something you went over in homework, or you went over in class, or you got wrong on your test, and I'll go through and do this. Yeah, Antonio, nice. You're very welcome, dude. Yes. I was going to say, like, let me just see if we get the same answer with ChatGPT, and I think we do. So, look. This is so funny. It says, this is a standard result. Dude, fuck you, ChatGPT. What? It says, this is just standard? Okay. But let's see. So, after us doing all this work, right? Let's see what ChatGPT got. One sec. I don't want all this. One sec. Not that. So ChatGPT got e to the 3x. Okay, here we go. 3 sine 4x. Okay, 3 over 25. I agree with this. They did e to the positive 3x. Oh, I see. Well, okay, my answer was minus 3. It didn't you know what's funny? It didn't read your screenshot correctly. Yeah, it thought the answer was e to the 3x, not e to the minus 3x. But it looks about the same. And then 4 cosine 4x. 4 over 25. Yeah, great. Awesome. Cool. All right, that works. Nice. Good. Ask it, dude, it just does it saying it's a standard thing, dude. Look at this. It just said this is a standard result. E to the ax sine bx is e to the ax over a squared plus b squared, a sine bx minus b cosine bx. That was integration by parts. We did integration by parts. Nice, zero regrets. Says, bro, I love that you just stream math. This has really helped me with my engineering. Yeah. Like, subscribe, follow, whatever platform you're on. Turn on notifications, because yeah, if you ever have questions, or questions that you need help with, more than likely I'll be streaming on one of those days and I can help you with it. Yeah. How do I know how to do this? I've been doing it for like 15 years. I've been tutoring calculus for a while. Yeah. Okay, cool. All right. Nice. Good question, Antonio. Let's get Becky's up on the docket. Ooh, Becky, you do have a fun one. Ooh, we got a geometry proof coming up. Do I know discrete? Kind of. Discrete's a little tough. I never took it. My PhD's in physics, so the highest I took was yeah, thank you so much. You're very welcome, Antonio. Yeah. I definitely do diffie-q. Yeah, I can do diffie-q. All right, let's see this one. Becky says, a quadrilateral ABCD is inscribed in a circle. Line AG is tangent at point A. Okay, cool. So if something is tangent I know automatically that this is perpendicular, right? I'm just going to start writing some stuff that I think I know is true. Oh no, you failed your physics exam? If you failed, send me a screenshot of a question that you got wrong, and I'll make sure you don't fail it on the final. Yeah? Is that good? We like that? Okay. Point E is the intersection of the diagonals of the quadrilateral, and point F lies on the diagonal such that angle bag... Okay, get a bag, dude. Okay. So this angle is equal to CDF. Is equal to this angle. Oh, okay. Wow. This is such a fun one, Becky. Thank you for giving me this. CDF. As long as I don't have to draw any auxiliary lines, I'll be happy. If I have to draw auxiliary lines, I'm gonna get so mad, dude. I hate the auxiliary lines. Variable resistance. Send me an example of one. I don't know what that means. Like a circuit? I can do circuits. Okay. Prove that AD over DC does not equal AF over FC. Interesting. Prove that it doesn't. Usually you prove that something does. Right, Becky? We're proving that something doesn't? Okay, so I want to prove that this over this does not equal AF over FC. Probably a proof by contradiction. I agree. Probably is like some what the fuck is a contradiction here, though? I think, yeah, we show that probably that these two angles would have to be equal for that to be true. ADDC 8 ADDC. Let me mark these so I can kind of see where they are. ADDC. Okay, so we're gonna say this line. I'm very sure AC. Yeah, no, you're right. So this is wrong. I can't say this is 90 degrees. Yeah. Only if it was going through the center I could. I was hoping it would. But you're right. I can't say that. Okay, then AF I'm going to do is like light green. So we're going to say this to FC. Which is this. Is E the center of the circle? I don't... No, it just says it's an intersection of the diagonals. Yeah, it doesn't say anything about being the center. That's unfortunate. Thank you, Abadi, for your question. I see it too. And then the other thing they have is prove that AFD is congruent to BCD. BCD. Oh, okay. Wow, this is wild. Super wild. Okay. It's a trapezium. Dude, it's all the shapes in one. Okay. Okay, well, I think this actually relates to the last question we literally just did, which was this one, right? I love math too, mate. I think this is very relatable. I think the angle bisector theorem we used here, I think this is going to get used in this somehow. I trust. Because I see like opposite sides of, and then I see like this. I think if we prove this is not the angle bisector of ADC. Okay, so let's think from the angle bisector point of view. I'm actually very interesting. Oh, please do. Yeah, if you want. Yeah. Yeah, you know what I'll do? I will enable a way for people to get the raw screenshots of what these images are. That's a feature update for me to put on the website. Yeah, that's a good idea. All right, so let's see. A over B. Let me just consider, for instance, this angle. Let me consider this one right here. Let's just consider it. I think what I want to prove is that these things are angle bisectors, and that the angles are not equal to each other. I think it's eventually what I'm going to do. That's the proof by contradiction. Okay. If that was true, so let's say, for instance, if angle FDC is equal to angle ADF, then by the angle bisector theorem, A over B. Okay, so that would mean that AD over DC, right? So this one over this one, which is this one over this one, would be equal to C, which would be this AF over FC. Okay, and I think what we're going to prove is that these two angles do not equal each other, right? Because this is kind of like an if and only if. Like we say this is like IFF, right? So the only way for this to be true is for this to be an angle bisector of these two, right? I don't think there's any other way for that to happen. So, thanks, Mess, for the heart. Mace, sorry. Okay, so this is interesting. I feel like this is another circle theorem. Circle theorems. All the circle theorems. Oh, wow, we actually have decent viewership now on TikTok. Nice. Look at that, 28. That's actually the highest I've ever seen on a live stream. Let's pull this in. Definition. I'm trying to think. One second, I'm waiting for this image to come in. Okay. Oh. Wow, thanks for the sub, Becky. UG, Becky. Thank you. I think this is something. Tangent lines. It looks a little bit more complex than geometry. I agree. Because, wait a minute. This requires that we know it's going through the radius, which it's not. Oh, here we go. Alternate segment theorem. This is what I want. I think this is it. I think this is what I want. I think this is what I want. Okay. The angle that lies between a tangent and a chord is equal to the angle subtended by the same chord in the alternate segment. Okay. So what they say is that this angle with the chord is also equal to the, like, the inner angle that makes that chord. Right? So let's look here. So I know this one is not true. Okay. That one. So let's see. That's the angle with this chord. Right? So here, let me like draw how this works. This is the green angle. Let me make this like or here, let me make this, I'll make this red. Well, no. Okay, whatever. So this angle, the thing that makes this angle, which could be either this or this. Wait, this or this, right? So either this makes the chord or either this makes the chord. Those angles need to also be equal to this angle. Do we agree with that? Oh, I think we're getting somewhere here. So this angle and this angle are the same. And that also makes sense. Because, if... yes, if the angle of the chord is the same chord, then the angles are the same. Yo, what's up, Jaden? Okay. No, they're congruent. Those angles are congruent. Yeah, for sure. That's what this says. So, look, for instance, whatever a tangent line makes with, like, a chord, these angles are going to be the same. And then also, this is a cool property from here, right? Yeah, okay. So, if you have a chord, let's say a chord DB, which gets made from this angle, but also gets made from this angle, then these angles also have to be the same. Your brain is being fed nice. Yeah, it's not brain rot. This is brain nourishment, dog. Okay. Cool. Okay. All right, so I think I see how this works. This is really cool because, okay, we also know that ABCD is a quadrilateral. Oh wait, but we don't. Wait. What's the rule of quadrilaterals? The opposite angles are the same, right? I agree. They all add up to No, they add up to 360. The interior angles add up to 360. How hard is calculus? I don't think calculus is that hard. God bless Dr. G. What? 19 bucks? Wow, what? Thank you, Sibley.
That's dope.
That's super dope. Thank you so much, Sibley. Wow. That's the highest donation we've had on YouTube so far, Sib. Thank you, Sib. God bless Dr. G. I appreciate that. Man. Let me see how I'm going to do this. I need to figure out also how to do like super chats, Sib, now. Man, dude, we are so close. Okay, what are like some quadrilateral properties? Yeah, calculus is totally doable in grade 12. Okay, here we go. This is what I want. This is what I want. This is what I want. Opposite angles add up to 180. Bro is Curious George. What do you mean? Am I Curious George? Yes. Okay, here we go. This is it. This is it. This is so cool. Okay, this is kind of like the other property I needed. Dude, geometry is all just a bunch of tools. Okay, the opposite angles add up to 180. Okay, so I'm just copy paste like all the theorems I'm using to do this. I think calculus is one of the easier classes to take because there's a path that makes sense. Pre-calculus, you're just learning a bunch of random topics. Like you learn about sine and cosine, then you learn about logarithms, and you learn about, I don't know, like exponential functions, and like all the stuff seems kind of scattered. But calculus has a definitive path. It's like you learn limits. Limits teach you derivatives. Derivatives let you do integrals, and then integrals let you do series or like whatever. Like it all makes sense. It all builds on itself. Yes, I did use... So what we're doing is we're going to disprove by contradiction the angle bisector theorem. But in order to do that, I need to show that this angle... Oh, I think we're already done. Yes, we're already done. We're already done here, right? Oh, yeah. Yeah, no. We're already done here. Right, okay, watch this. Because this angle equals this angle, and there's no way for angle FDC to equal angle ADF because there's an additional angle here. This is like whatever, right? So this is QED, yeah. Wow, that's done. Nice, that's super cool. Oh, we did it. That's super dope. Okay, cool.
Well done. Well done.
That's a very cool question, Becky. Yeah. I could write this up as a formal geometry proof. You almost failed your geometry test? Well, it's okay. I mean, you kind of got this. This is sick. Wow. Cool. Okay, we did this. I'm happy with that. That's so cool. So, to recap this, they wanted us to prove that this side over this side is not equal to this side over this side. And what we said is like, okay, well, that's... If that was true, if this angle divided by, if this side over this side was equal to this side over this side, that would be the angle bisector theorem, which would mean that the angles formed by bisecting this big angle with this segment DF, these angles would need to be the same, right? We said that, okay, if this was equal to this, then that would be true. This over this would equal this over this. However, by the... what was it called? What theorem do we use? Oh, by the alternate segment theorem from this and this, we showed that this angle, which we know is the same as this, that was given, is also equal to this and also equal to this. And so there is no way for FDC, which is just the blue, to also equal ADF, which has to be the blue plus something else. Yeah. So, assuming this is non-zero, and it has to be non-zero, right? Because, I mean, yeah, something with like this being a diagonal. There's no way to do it. I'm trying to like morph it in my brain, but I don't think you can. Yeah. Okay. Very cool. All right. Let me help someone else real quick in the queue. Becky, And then if we have time, I'll go do the other ones. But this was a very cool question. I really appreciate it. It reminded me a lot of things. Is HD bigger than AD? Where's it? What is HD? I don't see HD. What's HD? Huh? Yeah. Okay, nice. That's great. All right, let me get the next question up on the queue, which comes from Abadi or Abadi. Ooh, dot products, cool. Yeah, this is cool. I like this. Dot products are fun. Thank you, Becky. That was a really fun question. I liked how... Did you pick that question specifically because you knew we would be using the angle bisector theorem? Or was that just, like, happenstance? Yeah. Okay. Abadi, here we go. When appropriate, write the results in the basis. Okay. ER, E theta, EX... Why did I say E2 here? What? It should be EY. No. Okay. Consider two vectors in Cartesian basis. Completely accidental? Yeah, nothing's an accident, though. Nothing's a coincidence. Also, like, yeah, if you're doing geometry problems, you keep hitting the same theorems over and over again. All right. I want to write this in like vector form. I don't like this. I don't like writing this. Practice questions. Yeah, interpret acceleration, velocity, and positioning time graphs for a quiz. I have a video on it. If you go to my YouTube and type in like acceleration or position graphs or something, I literally have a video on it. One sec. Let me show them real quick. Omar, go to my YouTube, which is wait, that's my LinkedIn. Which is the same name. Type here and say like position versus time. There you go. Yeah, here's like how you draw position versus time graphs. And then how you draw velocity versus time graphs, and then how you draw like acceleration versus time graphs. So I have all of them. If you want to just go through, it'll teach you how to do it. Hey, do any videos to get better, Matt? Watching videos is great. Doing problems is better. Yeah. Okay. Adding vectors together, you just add the components, right? So a plus b means you just add this to this. So that's 2 minus 3, so that's -1 EX hat. And then -1 plus 4 is going to be +3 EY hat. That's a plus b. If you want a minus b, which is also... This is still a vector, by the way, right? This is 2 minus -3, so that would be 5 EX. And then this would be -1 minus 4, which would be -5 EY. So that's that. Dot product is cool. Dot product is you take each component, you multiply them together, and then you add what all the multiplications are. So in this case, for a dot b, we're gonna multiply the x components. So that's gonna be 2 times -3, and then we're going to do plus this one times this one, which is -1 times 4. And what you end up getting is -6 minus 4, which is equal to -10. This is a scalar, by the way. This is not a vector. This is just a number. That's -10. And then compute the cross product A cross B. Well, this is fun. If this is in the... X and Y plane, and you're crossing with something else in the X and Y plane, you have to get something just in the Z plane, right? If you cross the two vectors, yeah, you should just get something in the Z plane. I think you have to, right, Jeff? Yeah. This is a little trickier. You have to create like a matrix. Is what you have to do. Yeah, or it's magnitude A, magnitude B, sine theta. That's also valid. But the other way to do that is you say like, what is this? EX, EY, EZ. Wow, thanks. Yo, what's up, Penn Center? Yo, shout out to Penn, dude. How's it going, Penn? Haven't seen you around these neck of the woods lately. Well, I know we're all dealing with like crazy shit going on, especially with my beautiful government. Did someone say linear algebra? This is linear algebra. Where were you when I was in school? Yeah, Yeah. Okay. So then you set this up as 2 minus 1 0 because this has an EZ component, which is nothing, and then this is minus 3 4 0, and then you got to do cross products, which is like the determinant of this matrix. So higher education is taking a big F right now, and I'm on the union and the chair. So many arrows. Oh, dude, I feel for you, bro. I'm so sorry.
You done messed up, Aaron!
Yeah, dude. Everyone in higher education is getting fucked right now. I know, myself included. I was supposed to teach this fall at UCLA, and then nope. And just like, nope, not happening. I'm like, okay, well, you still have students. So who's teaching the students? It's okay. More time for streaming. I've been doing a lot of streaming recently, which was fun. Okay, so you do this times this minus this times this. So that gets you 0, which, yeah, we already know that, right? This is also going to get you 0. So actually, you just have to do this component. Only the Z component survives. And so that becomes 8 minus 3. So that's equal to 5 Z hat. Wow. Cool. 005, correct. Yes. The other way to write that would be 5 EZ hat. Nice. Yes. Oh, I forgot. Sorry. Let me make sure I shout out Zach too. Zach's awesome. E to the 2 iPod. Yes. I have to wait 160 seconds? Wait, I have to wait 3 minutes to do another shout out? Ew. You need help with statics, Chuck. Okay, cool. Submit a screenshot. I'll do it. An October schedule by end of the week. Sweet. I'd love to get that going. Yes. Yes. Pen, I love, by the way, your calendar. So I keep telling everyone to. So I built this actually now. I have a cool little widget here for people to submit screenshots because we're streaming on TikTok and YouTube as well, and so it's kind of difficult for them to like get into Discord, send a screenshot, and then have that also like come to me. So I just built this website where they can just drag and drop, and I can then work on it kind of live. But I love that you have. I love your calendar. Please never get rid of this calendar, or at least let me know so I can like make another one. But I use this a lot to tell the students because they always ask me like, when else do you stream? And I'm like, I'm not the only person that streams. We have other really awesome people that stream. So like Zach streaming on Saturday. Yeah, I'll share all the code with you if you want. Yeah, it's not I vibe coded it. I vibe coded it with ChatGPT. And it's hosted on a like a Linux server I have. Nice. Oh, Nanyas. Yeah, awesome. Yeah, I love the calendar. I'm a big fan of the calendar. I want more people to use the calendar. I don't know. Some people I feel like are resistant to because they think they're joining like some club or something. I don't know. They're weird about like I don't want to be a part of or something. I'm like, no. I just need to know your schedule so I can tell other people when to find you. You're not signing away your life. But thank you, Pen. Okay, cool. Let me see. I think I'm gonna just in the interest of time because I have like 10 more minutes before I have to leave. I'm gonna stop with this, but Abedi, I hope that helped you out. That makes sense to you. Yeah, Nanya says I love the schedule. Yeah.
Well
Okay.
done! Well done!
Let me speed run through these 2 questions real quick. I'm worried that Jeff might show up in the chat. You should stream. Yeah. I will find you. It's a gamble you have to take. Okay. Nanya, let's see this. You need to factor these? Okay. Well, ooh, I don't know if this can really be factored. Maybe. Okay, whatever. Actually, it can. Add 1 to both sides. 4x squared minus 1 is equal to 0. Then this is a difference of squares, right? Whereby a squared minus b squared is equal to a plus b, a minus b. In this case, a is 2x and b is 1, right? This is the same thing as 1 squared. So you get 2x minus 1, 2x plus 1. That's the first one. Okay? Sorry, I'll just underline them as different colors. This one, x squared minus 6x minus 16. This is a really nice, like, perfect square trinomial thing. So I just say, like, what two things multiply to negative 16 but add to negative 6? That's negative 8 and 2. So negative 8 times 2 is equal to negative 16. Negative 8 plus 2 is negative 6. And so your solution here is just x minus 8, x plus 2.
Good job.
That's another way to do that one. And then this one is, again, another difference of squares. This just becomes the same thing as 6 squared minus y squared, which is equal to 6 plus y, 6 minus y. Yeah. Nice. Does that make sense? Inari? Yes. Okay, awesome. Great. Sweet. Good stuff.
Well done. Well
I saw something with... You should solve the first equation. Yeah, well, is 1/2 and minus 1/2, right? Yeah, it's an easier breakdown for sure. All right, let me see if I can speed run this one real quick, because then I got to go teach another student. A laser beam shines along surfaces of a block, blah, blah, blah. Half the beam goes straight to the detector. The other half travels through the block and then hits the detector. The time delay between the two is 6.25 nanoseconds. What's the index of refraction? This is a great one.
My man.
Okay, so index of refraction, N, is equal to C over V. So this is the velocity in the medium. Okay, laser beams usually go at the speed of light, right? Because it's light. All right. So this one, the top beam is going to travel at its velocity is equal to C. This one is going to travel at a different velocity because it's going through through the medium, and that's going to be velocity is equal to, from here, if you just like switch these, it's going to be C over N. Okay? Now, we know that there's a time delay. Okay. Wait, I think I need to know the distance of the... Don't I need to know how long this thing is? Oh, I do. No, it's 2.5 meters. Okay, cool. Okay, so here's a cool thing. Distance is equal to velocity times time, right? So time is distance over velocity. So we can say d over t is equal to, or d over v is equal to t, all right? And so d over v1 is equal to t1. Let's call this like v1, let's call this v2. And then d over v2 is equal to t2. And then what we know is that the difference in the times, so t1 minus t2, but t2 takes longer. So I'm going to say t2 minus t1 is equal to 6.25 nanoseconds. So that's 6.25 times 10 to the minus 9. And that is also equal to d over v2 minus d over v1. I definitely do. Yeah, for sure. Okay, and then... Oh, okay. Oh, and we already have this. Yeah. And then... Yeah, okay. V1 is equal to C. So here, let me copy this. So that's equal to D over C. And then V2 was equal to C over N. So then this is C, so this is dN. C over N on the bottom. I can next time. I'm going to have to end the stream here pretty soon. Okay, so now the last thing is to solve for N. Okay. Oh, one sec. I got to reset this. Oh, it's going to get to it. There you go. There you go. Yeah, it's really cool actually. This is pretty cool shit. Okay, cool. So 6.25 times 10 to the minus 9 plus 2.5 over c. I'm just doing algebra at this point. And then all of that times c over d. That should be equal to n. So c over 2.5. Okay, bust out the calculator. Let's get this thing shipped out and done. This is physics, is what this is. Sorry, let me move this over. Okay, so 3 e to the 8 divided by 2.5, cool, times 6.25 e to the minus 9 plus 2.5 over 3 e to the 8. Speed of light c is 3 times 10 to the 8. And that gets me an index of refraction. Ooh, that's a really nice number. 1.75. So n is equal to 1.75. And that's your index of refraction. Okay. So, hope that helped you out. H. Nice. Okay, cool. All right, with that, let's close out the stream. All right. Thank you, everyone, for coming to Actual Education Office Hours. Really appreciate all the questions. I love my community. Thanks, everyone, for the suggestions, the help. Again, I'm not the only person that does this. Please, we have a whole list of other math streamers. If you're watching here on Twitch, you should go check them out. I'm going to give a shout-out to Zach because I'm doing an interview with Zach next Friday, I think, Zach. Is that what we're doing it? Next Friday? It'll be on the calendar. But make sure, go to the website, link down below, submit that education, or actualdiscord.com/submit. Here you can follow us on Twitch. You can join our Discord if you want to talk with us more in our community. People have donated today. I really appreciate all the donations today. This is the most donations I've gotten in a single stream. Thank you guys. Love that. And yeah, make sure to check out the schedule. If you check the schedule here, you're going to see the next time we stream, which I have an interview with Tiny Toxic Tofu tomorrow at 11 a.m. I'm going to be talking about physics and education. Go check that out on Friday. Zach, who's in the stream here, is Either2iPie. He has a math help stream on Saturday at 9 a.m. So for you early birds, if you want to get help over the weekend. And then I will be helping people as well on Sunday. So check this calendar if you want to figure out when you can get help. Yeah, start watching. Yes, nice. Like, subscribe, all this stuff. Everything's recorded. You can always watch it again. All right, I need to go teach another student for money because I have to pay my rent. But if you're watching us on Twitch, we're going to go raid somebody on Twitch. We have a lot of really fun partners and friends on Twitch that do stuff. Let me see. Science is starting. High potential. Neon Gus, blah, blah, blah. Go say hi to Nerduino. Nerduino's a really cool space and astronomy guy. He does, if you're interested in the cosmos, go say hi to him and stuff. But yes. Taco, you loco. Yes. Okay, cool. No more doom scrolling. Yes. Maxing. Yes. Cool. All right. Love it. Enjoy the weekend. We will see you guys on Friday, or if not, we'll see you on Sunday. Peace.